Yes, hello everyone. So today we are discussing a concept which is called pseudo force. Okay, so we'll begin with this. So the concept is pseudo force. So as the name suggests, pseudo force, pseudo meaning not real, right? So it's a force which is not really a force, but it feels like a force. So that's why while writing equations, if we consider it to be as a force, in some reference frames, our solution or our calculation will become much more easier, right? In mechanics, while solving questions, the problem solver has the freedom of selecting the reference frame. So while selecting the reference frame, if you choose in a informed manner, then you can solve that same question in a much easier fashion. So that's where the pseudo force concept comes in as important. So let's first understand this. And I feel that many of the students are having a problem in imagining pseudo force, or finding it difficult to understand so why we are learning it, even though when it is not a real force. So to understand that, I'll take one example. Example I am going to take from HC Verma. All of you know the HC Verma book, right? So with from there, I'm going to take this example. It's a very nice example for a student to understand or get a feel of this pseudo force. So imagine there is an observer who is on the ground, right? Let's call it as observer A, and there is another observer who is in a lift here. Imagine this to be as a transparent lift. You can imagine it as made up of fully glass, and this is like this, a lift is there, and there is another observer who is standing inside this lift, and within this lift we have some object. So let's take that object as something like a lamp or a something which is hanging from the roof of the lift. Okay, so this observer A, this is observer B. Now let us assume that this lift is going upwards with an acceleration of A. All right. Now, if you ask these two people, assume them to be as a physics student. So you're asking both the physics students to write the equation for this lamp. Right? Newton's laws equation, free body diagram you draw, write an equation for the lamp if you say, then both the people will do the equations according to their reference frame. So if you ask this point A person, then what would he say? The observer A would say that the lamp is inside the lift and the lift is moving with acceleration. So the person, observer A, would say that the lamp is experiencing a tension force upward direction, and the lamp is also having one mg downward direction. And the observer A will write the equation as, because it is moving upward, so definitely for him he will write T minus mg, that is the tension upwards minus mg downward, should be equal to the net force. Why he is writing it as a net force? Because he knows that it is moving upwards and that net force is still some value ma. And what is that A? This is the acceleration with which that lift is moving. With same acceleration the lamp is also moving upwards. So this would be his equation. But if you ask the observer B that what is his equation, what would he feel like? So he will say that I am inside a box, which is the lift, and that lamp is also inside the box. I am stationary with respect to box. So is the lamp. Lamp is also stationary with respect to box. So according to him, his equation would be what? Tension upwards minus mg downwards should be equal to net force, but according to him that net force equal to 0. So he would say that tension equal to mg. This is what his result would be. Now you can see that for the same body, I am having two different equations saying two different things. So if you ask that who is correct here, who is wrong here, then we can say that the observer A is the more accurate one, because the observer A has considered the acceleration into the picture, whereas the observer B has not even considered that acceleration in picture, right? So that's a problem with the observer B. He's not able to write the Newton's law with the acceleration in consideration because of his reference frame, right? He's not able to include that. Now, to include that for him within his reference frame, we are going to now consider a concept of pseudo force. So this is kind of like an adjustment to Newton's law, because NLM law, the equation that we are writing, these are not applicable for moving reference frame with its acceleration. That means we call the reference frames by two names, if you know, inertial reference frame and non-inertial, right? So this can be considered as a non-inertial reference frame because the reference frame itself is accelerating, and an accelerating reference frame is always considered as non-inertial. For those reference frame, you can see the equation is not valid. So to make it valid, we'll consider one extra force. So now the person B can correct his equation if he adds one more extra force into this FBD. He should understand that he is in a reference frame with his accelerating, and this accelerating reference frame will create one extra force called pseudo force in opposite direction to the acceleration. So what is FP? FP is the pseudo force. And which direction this is acting? The direction would be always opposite to acceleration of reference frame. Okay, very important. So direction would be always opposite to direction of acceleration of the reference frame. In our case, the reference frame, that is the lift, is accelerating upwards, so the pseudo force is acting downwards. Okay, then what about the magnitude? There is a fixed magnitude for this also. So if you are looking at an object, the object that we're considering is a lamp. The lamp's mass is given as m, so the force will be given as mass of that lamp into the reference frame's acceleration, which is a. Now with these things in consideration, let us rewrite the equation for the observer B. Now the observer B will say that yes, still I see the lamp as stationary, but now what all forces are acting on the lamp? So he'll say tension is acting upwards, minus mg which is acting downward, minus fp also which is acting downward, the pseudo force. Together it is making it into equilibrium, that is at rest, like that. So now we can say that T minus mg equals to fp, which is also equal to ma as per the rule. So now you can see that I am getting an equation T minus mg equal to ma, same as the previous equation of the observer A. A very nice example for you to get the feel of the situation, right? So observer A was able to write a proper equation because with respect to the reference frame of observer, he was able to see everything that is happening, the acceleration and all those things were considered. But with respect to the B, it was difficult for it to write the equation of motion where acceleration would be also considered. And that's why we added one force. It's not really a force, but we added a force called as pseudo force. And with that pseudo force, now both of their equations are matching. So conclusion here is pseudo force will be only required for those observers who are writing the equation of motion in a non-inertial reference frame, that's an accelerating reference frame. For all other observers, there is no need of pseudo force. They can write the Newton's law or the equation of motion directly without any problem. Okay, so one more thing, that how does the pseudo force, how can we imagine or we can understand the pseudo force in a different way, like in a physical sense, how can we experience it? So one best example that everybody in all textbooks would be, you might have heard that, it's like everybody says the same example. If you are inside a bus and if the bus suddenly accelerate, right, if a bus is accelerating and you feel that you are being pushed backwards, right, it's not really pushing backwards. I hope you understand what I'm saying. You're standing in a bus and the bus suddenly accelerates, you feel like you are being pushed back. Okay, the reality is what, it's basically inertia. Your entire body was initially at rest. Okay, your leg is in contact with the floor of the bus. So the moment the bus starts moving, the leg also starts moving, right? But what about the upper body? The upper body is not in close contact with the bus. That's why the upper body feels some inertia backwards. It takes time for the upper body to come to motion, whereas your leg has come to motion immediately. So leg remains there, the upper body goes back. That's why you have a feeling of falling backwards. Same thing happens in the other way. If the bus breaks suddenly, if the bus is braking suddenly, the leg which is in contact with the bus would immediately come to stop. Whereas the upper body, which is far away from the bus, that the contact is not proper, so the upper body would take some time to stop. So the leg stopped, but the upper body is not stopping, so it will move forward. So you have a tendency of falling forward. But you can say that's as if somebody has pushed you from the back. So this is like the a way of describing. So pseudo force can be considered as basically an effect of inertia, but yeah, you can call it as a force so that our equations can become proper. So this is the basic concept of pseudo force. I am hoping that all of you understand this. And pseudo force should not be used always. It will be only used with respect to a reference frame which is moving. Another very good example of pseudo force is centrifugal and centripetal. I bet all of you know this. Centripetal force, okay, is a force experienced by any body which is moving in a circular motion. Earth experiences centripetal. Earth has a centripetal force. It's experiencing a centripetal force. Only when there is a centripetal force, Earth can revolve around. Same way, a stone, if I tie to a string and I whirl it, the stone is also experiencing a centripetal force. Then only that is the reason it is performing a circular motion. So centripetal force definition is like a force which is always acting radially to an object, perpendicularly to an object, radially inwards in the circular motion. That kind of a force is called as centripetal. Centripetal is not really a force. You cannot just say that centripetal is a new force, like friction force, normal force, centripetal force. Not like that. Centripetal force is like a category of force. It contains many forces. Like for example, if Earth is revolving around the sun, then what is acting as the centripetal force? Then the answer for that is gravity. Earth and sun have a gravitational force. Because of that only the Earth is revolving around the sun. The moment you cut the gravity, imagine that gravity is vanishing at particular moment, then what would happen to the Earth? It will be just thrown off the orbit in a tangential direction. Earth won't be able to revolve around the sun. Same way that the stone and the string example, if I'm whirling it and suddenly somebody comes and cuts the string, then what would happen? The moment they cut the string, the stone would be thrown off the orbit, right? So who is acting as the centripetal force here? So in that case we can say it is the tension force in the string which is acting as centripetal. Now I hope you understood the concept of centripetal. Why I took so much of time to explain that? Because there is one more force called as centrifugal, right? What is this centrifugal force? It is a pseudo force. So you have to understand that any body which is moving in a circular motion would always experience a centripetal acceleration, which is given as v square by r, or you can also write it as omega square r. You may be knowing these two formulas. Centripetal acceleration, right? Now we just now learned pseudo force is given as what? Mass into acceleration. So imagine a body which is moving. Let us say we assume a disk which is rotating. So we have taken a rotating disk, let's say like this, and a person is standing on this lift. So our observer is on the disk. Sorry, I said lift, I believe. So the observer is actually standing on the disk, and the disk is undergoing a rotation with, let us say, omega angular velocity. And that observer is looking at some box which is lying on this disk. A box is there which is lying on the disk, and the observer is looking at it. So my question is, the observer, isn't he on a moving reference frame, an accelerating reference frame to be precise? Yes, any circular motion will always be having one acceleration, and that is what? AC. It's always there, right? Now because of this AC, there will be also a pseudo force for this man. Because a man is in a reference frame which is accelerating, definitely he should be applying a pseudo force. He should always use a pseudo force to solve the question. So my question here is, which direction is the pseudo force? Pseudo force always acts in opposite direction to the acceleration of the reference frame. Acceleration of the reference frame is centripetal. Which direction does centripetal act? I told you it always acts in the direction radially inward. This is the direction of the AC, centripetal acceleration. If that is the case, then pseudo force, the FP, should always act in opposite direction to that, that is radially outwards. And how much is the magnitude? It will be m into AC. AC is nothing but v square by r, or the other formula that you can write is m into omega square r, right? So centripetal force and centrifugal force are coming out to be having the same magnitude, but the directions of both these forces are different, and what they mean is also different. Centripetal force is like a real thing that is there, whereas centrifugal is a pseudo. Only when you stand on that reference frame which is rotating, then only you will be seeing the centrifugal. If you are on the ground, with respect to ground, there is no centrifugal force. Okay, that's also an example of the pseudo force. So I'm hoping that you understood the concept of pseudo force, a very powerful tool to solve many questions like block on block questions and all. It can be made very easy when we use pseudo force. Okay, so we'll stop here then. Questions of this you can see in the later part of the videos in the playlist. Thank you.